Welcome. What I'd like to do is show you how to solve word problems using inverse trigonometry. So just like we used trigonometry before, for the basic functions, sine, cosine, and tangent, that was to find, the length of a right triangle basically being the length of the adjacent, the opposite, or the hypotenuse. Well, in these problems, what we're looking for is the angle. So we're still going to follow the exact same steps. We're going to find our right triangle because we're using trigonometric functions. We're going to find our right triangle. We are going to place in the side lengths, the hypotenuse, the adjacent, and the opposite. We're going to determine which trigonometric function we are going to apply. And then we're going to use inverse trigonometry to go ahead and find the angle of what we're asking for. So in the first example, number 1, it says a 20-foot ladder leans up against a wall. If the ladder is 3 feet from the wall, what angle does the ladder make with the ground? So in this example, the first thing, guys, is I would just say, create a wall. All right, so create a wall. And then we have a ladder. So the ladder is going up against there, right? And if you want to get nice and pretty with your stuff, that's perfectly fine. But you don't really need to. We know we have the ground, right? So it says this ladder is 20 feet. And the distance away is going to be 3 feet. And then what they're asking is, what is the angle? What angle does the ladder make with the ground? So here's your ladder. Here's your ground. So you can say, we're basically looking for that angle theta. Now again, to solve this, there's a couple things. We want to create the triangle. So I can just kind of create my right triangle here, like this. And we can say 20 feet, theta, 3 feet. And then we want to determine which trigonometric function we're going to need to be able to solve for theta. So we look at our trigonometric function. We have our right angle. We know that across from the right angle is our hypotenuse. And the angle between theta and our right angle is always going to be our adjacent. So we have the adjacent side and the hypotenuse. So therefore, we know we're going to need to use the cosine function, because cosine of any angle is going to be the adjacent side over the hypotenuse. So in this case, we have cosine of theta. Actually, I'll do this here. Cosine of theta is equal to the adjacent 3 feet over 20 feet. Now, to actually solve for theta, we need to undo cosine. So therefore, that's where we come in with this inverse cosine. So basically, we're going to inverse cosine both sides. Kind of looks like this. And therefore, we're just going to be left with theta equals cosine inverse of 3 over 20, because the feet now will divide out. So now what we need to do is just type that into our calculator. So we want to go on our scientific calculator. And when you're doing this, make sure you have your calculator in degrees. Since we're given a problem that's in degrees, we're going to want to make sure our calculator is in degree mode. And then usually on your phone or what else, you have the trigonometric function, then you have the inverse trigonometric function. So I'm just going to do inverse cosine. So for my calculator, I have to do second cosine. And then I'll just do 3 divided by 20, and I'll close my parenthesis. And you can see I get 81.37. I didn't say how to round this, so I'm just going to say for all these problems, I'm going to want to round to the nearest degree. So in this case, my theta is going to be 81 degrees. And then just make sure you have that degree symbol, because that's going to be representing what exactly our unit is. All right, in the next one, it says a building is 550 feet tall. If you are standing 1,300 feet away from the building, away from the base of the building, what is the angle of elevation to the top? All right, I guess we have 2 angles of elevations. OK, so you have a building, right? And that building is 555 feet. And they're saying you're standing. Let's see here. You are standing 1,300 feet away. And they want to know, what is the angle of elevation to the top? So again, we're looking for the angle of elevation. So in this case, you can see we're looking for our theta. But in this case, we have our opposite and our adjacent side. So if you remember, the trigonometric function that's going to help us with opposite and adjacent is going to be tangent. So I can say tangent of theta is equal to 555 feet divided by 1,300 feet. Now again, just like we did before, instead of using inverse cosine, now we're going to use inverse tangent. But the result's basically the same. We're going to have theta is equal to tangent inverse of 555. You could reduce this, or you could just type it all into your calculator, which I think is probably going to be the easiest. So we will do second inverse, our tangent inverse of 555 divided by 1,300. And I get 23 rounded to the nearest whole. I get theta equals 23 degrees. Okay. In this last one here, we have a 500-foot wire is fixed to the top of a 370-foot tower. What is the angle of elevation? So kind of the same thing. Again, the purpose, guys, is to create some kind of tower. Doesn't really matter what the tower looks like, but create some kind of tower. And then we have a 500-foot wire. So is fixed to the top of a 300-foot tower. So a 500-foot wire is fixed to the top of a 500-foot wire. I think I forgot to write in is fixed from the top of a 370-foot tower to the ground. My bad. To the ground. Now, what is the angle of elevation? So what I was trying to say is there is a 370-foot tower. So from here to here is 378 feet. Then you have this 500-foot wire. All right. And so now what we're looking into doing is identifying theta. So again, we need to look at what is my trigonometric function, or basically where it's, well, we kind of know what my triangle is. You could say we have our opposite and we have our hypotenuse. So therefore, we know that the sine of our angle theta is going to be 378 feet divided by 500 feet. Therefore, theta equals sine inverse of 378 over 500. So I'll just do second sine. So it'll be sine inverse of 378 divided by 500. And that's going to give me theta equals 49 degrees when rounded to the nearest whole digit, or degree. So there you go, ladies and gentlemen. That is how you solve word problems using inverse trigonometry. Thanks.